Welcome back to the SolarPunkPro podcast. As I have shared on this channel many times, I have had the joy and luck of being able to work in the electrify everything and power it with the renewable energy industry for just about 2 decades. Along the way, I've had the privilege of wearing many hats, sometimes at the same time. One of our projects, I was able to go from sales and design to project management. The lens in which I viewed maybe the hardest project I've ever worked on changed dramatically as I stepped from one hat into the next. This project was a solar carport over a surface parking lot. I built it on Helioscope. It's the design software we use to model solar production, and the numbers look great. I was able to draw out these beautiful rectangles that made sense with the known span of our trusted carport manufacturer. Had a good angle, good sun exposure, straightforward structure. We did this initial site visit and nothing jumped out from the electrical. Jesus, is this project going to be a clean one? Ha! It's construction. It is never going to be clean and straightforward. By the time we finished this project, we had hit underground utility conflicts, not actual hit underground utilities. We had geotechnical surprises that tripled our foundation depth requirements, a downtown Boston parking standoff that I may never get entirely over, a global pandemic, and construction crews working directly outside major law enforcement headquarters during some of the most intense public demonstrations this country had seen in decades. But we finished on time. We finished on budget, and I learned more about what this job actually requires on that single project than I had in years of routine installs. This is what solar work actually looks like when the puzzle gets complicated, and if you are thinking about building a career in this industry, I want you to understand both what goes wrong and what it takes to get it right, and why you will never, ever get bored working in this industry. The project was a solar carport for a large municipal law enforcement complex in a major northeastern city. We were brought in through a general contractor who was doing a package of significant energy efficiency upgrades across a number of municipal buildings. Our piece was the parking lot carport. The design phase, it went smoothly. The site visit went smoothly. And then we did underground utility locate. The site, it had drawings of where the electrical was, so this was just a triple check that those locations were right. It's a corner, honestly, we could have cut. The drawings were not that old, but it's relatively inexpensive compared to how much it costs if and when you actually hit something. Well. We found the main electrical service line running directly through the footprint of the carport. Specifically, it came right where approximately half of our structural posts were going to go. This is the moment in a project where you have 2 choices. You can panic or you can problem solve. We problem solved. The redesign extended one of the carport tables, making it longer to bridge over the utility corridor, which then pushed the structure out over the entrance to the parking lot. New clearance calculations, new structural loads, new drawings back to the city for approval. We confirmed the height clearance was going to work for vehicles entering the lot. We had a workable solution, new design locked in, time to move on. This is the first thing I want you to understand about real solar project work. The design you start with, it is almost never the design you finish with. The ability to redesign quickly, communicate changes clearly, and keep all the stakeholders aligned while you do it, that's the job. With the electrical conflict resolved and the redesign approved, we moved to geotechnical investigation. These are drilling tests. They drill borings to understand what the soil conditions were so that we could spec the right foundation depth for the carport posts. Standard carport piling depth is around 8 feet. That is what we budgeted. That's what the design assumed. What the geotechnical report came back with was 18 feet. Here's the thing about Boston that maybe most people don't know. I knew it conceptually, and maybe I should have guessed this was going to be an issue because significant portions of the city of Boston are built on fill, loose debris, rubble, and landfill that was used over centuries to expand the original landmass into the harbor and surrounding marshland. The Back Bay neighborhood is literally filled in. Large parts of downtown, same story. The ground under a parking lot in Boston can be a very different animal than the ground under a parking lot in Ohio. 18-foot pilings instead of 8-foot pilings means a completely different drilling rig. It means significantly more concrete and steel. It means more time on site. It means a line item in the budget that wasn't there before. It also means you cannot fabricate your structural columns in advance because you do not know the exact finished depth until you have drilled each hole and confirmed what you are dealing with. So, we are fabricating columns on site in real time in a tight urban environment as each boring was completed, which brings us to the parking lot. To install an 18-foot deep foundation system with a large drilling rig in a downtown parking lot, you need the parking lot to be empty. This is not a negotiable construction requirement. A multi-ton drill rig, it needs clearance, staging space, and the ability to move around the site safely. The problem was that this was the parking lot for a major law enforcement complex in downtown Boston in the summer, when parking in downtown Boston on a good day is already a contact sport. We coordinated with the facilities team well in advance. Notices went out. A nearby college was gracious enough to rent us a portion of their parking lot about a block and a half away. Not ideal for the people working at the complex, but it's workable. It's a block and a half. With a plan. And then the day came to clear the lot, and a meaningful number of vehicles simply did not move. We'd assumed the police would follow the rules. Well, we were wrong about that too. We ended up having to install construction fencing to physically prevent vehicles from re-entering the work zone, an expense that was in the original budget, but was to keep the public out. It had not occurred to any of us that we would need to fence out the people whose job it is to enforce parking regulations. The gigantic drilling rig, it had to navigate a tight urban footprint, working around parked vehicles on adjacent streets, utility access points, and the general chaos of a busy downtown location. The column fabrication was happening on site in real time, as I mentioned. The general contractor, they were also coordinating multiple simultaneous scopes of work under the broader municipal project. The logistics puzzle was dense. And then there was the context. It was the summer of 2020. George Floyd had been killed in May. The demonstrations that followed were happening in cities across the country, and Boston was no exception. There were significant public protests occurring in the immediate vicinity of our job site outside the very building we were working on. And I want to be honest about what that was like because I think it matters for anyone considering this kind of work. Our crew, they showed up every day and they did the job. But the environment, it was charged in a way that's hard to describe if you weren't there. You're running construction equipment. You're managing a complicated install, coordinating with a building that is simultaneously the center of significant public attention and tension. The human reality of what was happening in the country was present on that job site every single day. You figure out how to hold both things, the work and the world it's happening in. That's part of the job too. The project, it was completed on time. It was completed on budget. The carport, it is generating clean electricity over a parking lot in the middle of a major American city, and it has been doing so ever since. But I want you to understand what on time and on budget actually required on this particular job. It took a full redesign after the utility locate with new structural calculations and revised municipal approvals, an 18-foot foundation system instead of an 8-foot one, fabricated on-site in real time as conditions were confirmed. A downtown Boston parking logistics operation involving a college campus, construction fencing, and a level of negotiation with stakeholders that would have felt at home in a labor dispute. A crew working professionally and safely in one of the most socially and politically charged environments of the decade. None of that appeared on the original project scope. All of it had to be solved. The tool that made the project look oh so simple, Helioscope, was right about the solar production. It had nothing to say about what was buried underground, what the soil was made of, where the parking attendants were going to leave their cars, or what was happening in the streets outside. That gap between what the model shows and what the site requires is where experience lives. It's where judgment lives. And it's the part of this work that no software will ever replace. I tell you this story not to impress you with the complications. Every experienced solar professional has their own war stories and versions of this story, but to give you an accurate picture of what this work actually demands. It demands technical knowledge. It demands understanding soil conditions and foundations engineering and electrical systems and structural loads. The SolarPunkPro Masterclass, it gives you the foundational literacy to understand why these problems exist and what the solution categories look like. It demands project management, the ability to hold multiple moving pieces, communicate clearly when plans change, keep stakeholders from panicking, and find creative solutions inside real constraints. If you've managed anything complex in your current career, that skill, it transfers directly. It demands judgment, knowing when to escalate, when to problem solve quietly, when to push back on a scope change, and when to absorb it. That comes with experience. But it starts with understanding the landscape well enough to recognize what kind of problem you're actually looking at. And occasionally, it demands the ability to work well in difficult human circumstances. The world, it does not pause for construction schedules. This project is not the hardest thing I've done in 2 decades of solar work, but it is a great representation of what the job looks like when it asks something of you beyond what the design software predicted. If you like this episode, stay tuned for future episodes where I tackle other war stories. Next up, it is about a 1 megawatt commercial install where the real complexity, it wasn't on the roof at all. It was in 3 months of interconnection negotiations with a municipal utility that had never done anything like this before, a multinational client whose European headquarters had made renewable energy non-negotiable, and a lease structure that needed new language written from scratch. That one's a different kind of puzzle. And if today's episode gave you a real sense of what this work looks like, the kind of thinking it requires, the variety of problems it throws at you, and why people who have built careers solving complex problems in other industries are generally well suited for it, well, the SolarPunkPro Masterclass, it is your next step. It is built to give you the technical foundation to understand the landscape and the industry context to position yourself credibly within it, without having to go back to school, without starting over. The link for that class is in the show notes. Or if you would rather talk about your specific situation first, go ahead and book a free 30-minute industry analysis call with me, and we'll map it together. I'm James Manzer. This has been the SolarPunkPro podcast, and I will see you next week.